Thanks very much. So thinking back to one of the talks this morning, I'm going to be actually representing, speaking in three characters. I'm an earth scientist by background, spent many days in this room, so it's great to be back, both as a practicing earth scientist and also as former president of the PSGB. Second character I'll be speaking in at times will be as an employee of a major oil and gas company for many years, an oil and gas company that's been very innovative in the UK. Chevron drilled the first well, exploration well in the UK over 50 years ago. And the picture here is our Captain platform, where we've recently sanctioned a major chemical EOR project offshore, which is a global first. So we're still innovating. And my job is actually in technology at the moment. I manage a technology centre in the UK as part of a global technology organisation within Chevron. And then the third character I'll be speaking at times is as a representative of industry. And I've spoken to many colleagues in operators, universities, and in contractors about the topic of big data and what it means to us. We're trying to consolidate this. I'm a member of the Technology Leadership Board for the industry, and we're trying to consolidate that into a technology strategy for the UK. So I'll be touching on those different perspectives in my talk. So I'll start with some key messages. I'll talk about why technology strategies, it's useful to have a technology strategy for this to fit within. I'll then talk about facilities and above ground work. A lot of what we hear about in digital transformation is actually above ground. And hopefully you look at the logo of the Geological Society, which my Latin's not that good, but I think it means whatever's below the ground. So actually what is below the ground is different when we look at big data. So I'm going to try and explain why that's different. I'm going to offer some definitions around data science, because I think those are helpful when we're looking at framing up projects. And I'll finish with some industry perspectives, both from the company I work for and for the UK oil and gas industry as a whole. So really my key messages are the oil and gas industry has been on a digital journey for a very long time. And this is a next step in a long digital journey for us. Having said that, though, the subsurface is normally undersampled. So, you know, we were talking earlier about millions or billions of samples, billions of users providing information. For oil and gas fields, we're lucky if we have 10 wells. Sometimes in some onshore cases, we may have hundreds or thousands. If you look at the whole of the UK, you know, we're talking in a few thousand E&A wells. It's not that much data. So the subsurface is normally undersampled. And the things we measure in the subsurface are not what we want. So they're not oil or money. They're things like acoustic impedance or resistivity or a fossil. And we have to turn that into something, you know, that's of business value. When we're looking at definitions of data science, I think it's very helpful to realize data science lies at the intersection of disciplines. We talked about that earlier in one of the sessions earlier today. I will give some examples of business impact, though, from my experience, one of the teams I managed in California, and I'll talk about UK initiatives. The industry is really taking a bit between its teeth on this, I would like to think, and initiatives are underway. So, first of all, business strategy. So, if you look at Chevron's articulated strategies, they're in something we call, a document we call the Chevron Way. Very simply, we have three major business strategies for upstream, that's the exploration and production side of the business, the downstream of chemicals, so that's refining and marketing, and the midstream, which is transportation, pipelines, and so forth. And actually, even in the upstream, with the changes we've been through over the past 4 or 5 years, you'll see there's a key word there which is around returns. So yes, volumes and value are really important, but also the industry's increasingly focused again on margins and efficiency, which when you're looking at big data solutions, get people's attentions. I think one thing that helps me in my job is that those three major business strategies are actually linked to enterprise strategies, and one of those key enterprise strategies is to differentiate performance through technology. So this is really good. If you're going to our senior executives and stakeholders to talk about technology, they're expecting you to do that because there's a recognition it has a business impact. And that's a very helpful place to start. The big data opportunity clearly fits within that. A lot of companies and CEOs are under pressure to tell their big data story to investors. And so technology and defining big data is getting a lot of attention right now. But it's not new. And here's some examples of some prior digital transformations. That's another word we hear a lot at the moment, is transformation. Well, we've been transforming and changing for at least the 30 years of my career in the industry. And here's some examples of some fairly fundamental transformations we've had in relatively recent years. So down at the bottom in the subsurface, one example is reservoir simulation technology has been transformed. Chevron jointly developed the next generation reservoir simulation tool called Intersect, which is based down in Abingdon. That allows us to run thousands of runs, do proper probabilistic assessments, and handle complex depletion mechanisms like fractured reservoirs or chemical EOR. So that's been a real transformation for us in our subsurface work. Obviously, seismic imaging has been on a digital transformation journey for 30 years, and we're still making great strides in that. If I look above ground, though, or not above ground, the next layer up, you'll see there's, in that middle tranche of projects there's some projects called Upstream Workflow Transformation. And those are projects we actually did, basically over the 5 or 6 years. That program's ended now because those standardized applications for digital workflows have been deployed to many business units around the world. And you'll see things there like logistics, support solutions, facilities optimization, machinery and power solution centers. So, for example, for rotating machinery, if you've got compressors, they're pretty much the same wherever they are. So it makes a lot of sense to monitor them, aggregate the data, and look at them as a family, if you will, of equipment, much the way that aircraft engines are monitored in real time. And then over on the right, drilling and completions, we can monitor our wells, complex wells, some centralized decision support centers, and integrated operations centers as well. For our day-to-day operations are very common in the UK, in Norway, and in the US and other jurisdictions. So one of the benefits of having years of digital transformation is to support those upstream workflow transformation, for example, you have to get your data in order. Otherwise, it's not going to work. So those are positioned us quite nicely to actually move to this next generation of digital transformation. So as was mentioned in the introduction, it means many things to many people, right? So you hear a lot of words, and here are some words which I collated from what I've heard when I hear people talk about digital transformation. And some of those are in bold. You can see I've picked out 5 phrases at the top in bold. And the reason I picked those out is they were actually mentioned in a press release towards the end of last year, where Chevron announced a strategic alliance with Microsoft to look at analytics, data science, cloud computing. That would be the Azure platform that Microsoft have, machine learning, and the Internet of Things. So we've committed to at least one partner on those key things. And I think, again, for digital transformation, one of the things that's changing now is this Internet of Things. You can't buy anything that doesn't have a sensor, it seems, these days. Certainly our new upstream oil and gas facilities, like our complex LNG plants in Australia, that we just have brought online in the past couple of years, they've got hundreds of thousands of sensors on them. So we have to have big data and analytic techniques to be able to absorb that information and run our operations. That's a new problem to have. And for those of you, for example, who have bought a new car recently, it will have more sensors and can send all data to your app and on your phone. And more information again than you really know what to do with sometimes. So the Internet of Things in the facilities world is certainly upon us. Now, if you look at our industry and think again about the above ground stuff, particularly around facilities, one of the main challenges for us right now is to adapt what's already out there. So yes, Internet of Things solutions are already out there in many other industries. AI is out there, augmented reality. Some of you will have seen, for example, the HoloLens augmented reality glasses, which can be a great boon. Robotic process automation, 3D printing. We saw a nice example earlier, additive manufacturing of fossil samples. But what about components in the industry? Unmanned airborne and marine surveillance. Unmanned airborne vehicles are sometimes called drones, but obviously those are wonderful for inspection if you can stop having to put people on ropes to go and look at things at height. You take people out of harm's way and you can actually get better data usually. Similarly, marine surveillance or autonomous surface and underwater vehicles, huge step forwards. For example, the Natural Environment Research Council in the UK has a massive fleet of autonomous marine vehicles for collecting data with the National Oceanographic Centre down in Southampton. And then sensors and then digital clones, which is like building a building on the computer. That's very common from the construction industry. So a lot of our challenge is to take this stuff that already exists and adapt it. And particularly in the offshore side of the industry, that still places challenges. So for example, a tablet that, which we're used to at home, which we can take around on an oil and gas platform, so it's certified to operate in those environments, has only really those tablets are only just coming on the mass market in the past few months. And even if you've got them, you need to install 4G on your platform offshore, which is another major investment to actually be able to communicate in the way we're used to being able to communicate in our homes, for example. So adaptation is complex. Another example is robotics. There's a very nice story just got on the Chevron.com website in the past couple of days about a robotic field trial my group was involved in, where we took a robotic solution from the nuclear industry to put a snake arm into vessels to inspect them, pressure vessels. So you don't have to put humans into pressure vessels. But of course, you're going to take this nice robot from a controlled onshore environment and take it offshore onto a platform which is not a control, is not a smooth factory floor, shall we say, and in a marine environment. So there are challenges in adapting. And sometimes our industry gets accused of being a bit behind on the digital transformation, but particularly when you look at taking stuff offshore, there are challenges we have to overcome to adapt. So that's all above ground. Let's go underground. And for subsurface digital technology, I've seen us be on a journey for 30 years. When I started as an interpreter, a seismic survey was a box of paper, and I had colour pencils. And then we got 3D surveys, and then we got 4D, and now we're getting ocean bottom node data with long offsets, rich azimuth, high fold, massive data sets. And the next steps are autonomous acquisition. For example, if you had robotic source vessels, that would be a good, interesting efficiency. And then also fibre optics downhole. And fibre optics is a big data kind of challenge. We record much more data than we know what to do with. And so sampling that data appropriately, storing it, figuring out what to store for what purpose is certainly an emerging challenge. There are some very innovative companies, actually. Some of the leaders in the industry are in southeast England. There's some interesting R&D going on as well in the UK and other places around this. So for me, these are some of the key things in the next step in our digital journey. For interpretation, again, we moved from paper to digitizing onto a mainframe to having interpretation workstations to then having 3D models. When Jurassic Park came out, we then got Silicon Graphics 3D computers, And our next stage is, well, like ocean bottom node, we've got all this information, and how many cubes do we normally interpret? One. And how many realizations do we normally interpret? One. Right? How certain are we of those interpretations in terms of fault placement, stratigraphy, depth even, time to depth conversion? There's a lot of uncertainty. So having massive computing power could allow us to handle and carry some of that uncertainty through our interpretations, and also use AI techniques and pattern recognition. One of the challenges there, though, again, we often don't have enough wells to uniquely constrain the training set. Then hardware, again, we've been on a big journey from mainframe to workstations to clusters to massive data centers, and now the cloud is the next step. Again, we have to think about what that means for us when we're interpreters of large data sets that we don't want to pull it down onto our phone. It's slightly different to some of the other cloud applications that many of us are using for human activity above ground. So the next step is definitely exciting, but it is the next step on a long journey. So this was mentioned again in one of the early sessions, but our Earth science data is very diverse. It's, as I mentioned, we often have less wells than we'd like to constrain our solution, but the data we measure in those wells is often indirect. And here's a long list from a paper John Garrett and I published online in Geo Expro magazine last year, called Plan Before You Pick, Consult Before You Commit. And you can find that through searching online. But here's some of the data that we use in interpretation. And I can just pick out some things like that, like biostratigraphy or mudlog data or vertical seismic profiles or let me see, offset volumes or velocity models. None of those are direct measurements of where the oil is in the ground in depth, in space. They're all indirect. So that's a challenge for us. Not only are we sparsely sampled, but we're taking lots of complex measurements, actually very few of which are direct measurements of the thing we want to measure. And we may not even know where we are in depth, for example, in terms of spatial location. There may be depth uncertainty, there may be depth uncertainty in X and Y if we're drilling a long horizontal well. So there's lots of challenges with the data that we have, and it's very different to some of the stuff that we can measure on ground, where we know exactly where it is, at what time we measured it, and what we're measuring. That's very directly related to the problem we're trying to solve. So I don't want this to sound like an excuse. It's just a recognition that this is a little bit different when you go underground relative to the uses of big data above ground. So I'd like to move on to a definition of data science. Again, that's another term that is bandied around quite a lot. And in Chevron, we've learned that it's useful to think about data science as being, it's not a thing, it's at the intersection of three things. And top left, you need computer science. Top right, you need advanced statistics and multivariate correlation techniques. And then down beneath is the domain knowledge. So as Earth scientists, we're the domain knowledge folks, but we need to talk to our computer scientists and our statistical experts and combine all that to give us data science. And one thing that is different, to say the marathon of building a next generation simulation model, a lot of these data science projects are sprints, they're not marathons. And so you can get lots of information, fail fast, and learn iteratively to solve business problems. So where we're actually seeing, and when I say we, this is the industry as a whole, where it's easiest to tell the story of the impact of big data on our operations is actually the unconventionals in North America, because there are thousands of wells being drilled, lots of logistics with frac trucks and other logistic problems to solve. There's sharing of information between different operators, and you're in a factory mode that you can drill wells quickly, learn from one thing to the next. So actually, if you look at our upstream oil and gas industry, you can see the biggest impact on big data and data science from many operators, large and small, is in the unconventionals in North America at the moment, because it fits these criteria and you can do sprints rather than than marathons. So for us in earth science, we want to gain insight and generate business impact. I think when I was looking at this slide this morning preparing to talk, I was thinking as well, actually, we've been doing parts of this in the past. So if you look at the intersection between earth science and computer science, well, normally that's what we've called geophysics in the past. Or if you look at the intersection between earth science and statistics, that's what we call geostatistics. So we've had parts of this, but data science is putting things together in a new way for us in earth science. So another challenge for us is to frame our business decision properly. And again, this is another table from the paper that John Garrett and I published last year. So there are many reasons that we do earth science in the industry. Here are some. You'll frame a project very differently if you're trying to do a real-time incident response to the placing of a well as you're drilling it, to the design of a well, or a commercial decision on whether you're going to buy or sell, or license an exploration block, or do a field development plan, or build a simulation model, or assess the overburden integrity. You do very different things. So again, just throwing a lot of data into a machine expecting magic to happen isn't going to work. You need to be very careful to frame the problem according to the business challenge we're trying to solve. And as earth scientists, we work on a very rich variety of business problems in our industry. So it's really important to have clarity on what problem we're trying to solve, at what time scale, with what information, before we even go into the framing meeting with the computer scientists and with the data scientist colleagues. So having said all that, we have demonstrated business impact in Chevron from these technologies in the subsurface. And this is an example from a presentation to the security market, security analysts a couple of years ago. And the example on the right actually is from where I used to work in Bakersfield, where we did have thousands of wells. We'd had many years of enlightened IT managers who had got our data in good shape as a resource. We had heavy oil operations with thousands of wells and observation wells gathering data that was kind of similar, and it was of high quality. And so we could use that. We had enough data of enough quality from enough fields or reservoirs that were the same that we could actually apply these methods and actually find new opportunities, for example, to drill horizontal wells where some of our petrophysical cutoffs were maybe a bit aggressive. If we did the data mining and look at our models and what the well results actually were, it encouraged us to drill in places that otherwise we wouldn't have drilled before. And so you can see in parts of our fields we've demonstrated very clear production impact. But it's important to think about the conditions here. You know, many wells, similar reservoirs, many years of good IT management, getting the data in good shape, proper surveillance as well. And not many of our oil and gas fields have that amount of data on that scale with that consistency over many decades. So again, not an excuse, but just context for where we've been able to generate business impact up to now. So stepping back from Chevron to the UK industry, I'm on the Technology Leadership Board, and we're looking at the strategy for technology for the whole UK industry at the moment, working with the Oil and Gas Authority. Nick Richardson will be speaking tomorrow, and the Oil and Gas Technology Centre as well. So here's some themes about transforming exploration. We can streamline our workflows, and I think some people obviously react to the talk of AI as if it's a threat to jobs. Well, the reality is after the harsh conditions of the last 3 or 4 years, we have fewer geoscientists, and we don't have enough time, frankly. So streamlining workflows is a good thing because we need to make the best use of the time of the precious people we have. It's interesting to me, I was very involved in leading development of our 3D modeling technology 20 years ago. And if you look at the way we build models now, we still move a mouse around and click at things on a screen. it's very intensive, and if anything, our applications have got mousier over time. So there is opportunity to build better interfaces, so you have to do less mousing. We're in the midst of the great crew change, and actually some of the AI is an opportunity to actually codify some of the expert knowledge as those experts are going or gone. Managing data with digital assistants like robotic process automation we're starting to see in finance. That might be useful in our science data. Seismic processing, you might be able to speed up some of the steps in that. There's still an iterative process of generating products, looking at them visually to see if they're okay and making a judgment on what's good or not. We might be able to speed that up. Interpretation is ripe for pattern recognition, and some of the information from the virtual field trips will be useful to constrain that. And then one of the things I'm excited about at the moment is an industry study which we're launching with the Technology Leadership Board and the Exploration Task Force in the Oil and Gas Technology Centre to look for missed pay in the northern North Sea, where we do have, if you've got a basin scale between UK and Norway, we do have wells that can be measured in the thousands. We do have reasonable quality log databases, and we have some consistency in elements of the stratigraphy that this might work to look for missed pay, and we can find missed opportunities before the infrastructure is decommissioned. So you'll hear a bit more about that tomorrow morning. So to conclude, I've tried to provide some context on our 30-year journey, but a couple of key takeaways. Our subsurface below ground is different to above ground because it is normally very undersampled, and what we're measuring is not what we want to measure, right? It's indirect. It's a proxy for example, oil or gas. Data science lies at the intersection of disciplines, so earth scientists, go and find your computer scientists and statistical gurus and work with them. Business impact has been proven already, and the UK industry has got the enthusiasm and got some projects framed up to apply this to the industry as a whole, as we continue to find ways for technology to impact performance, not just of the company I work for, but for the industry as a whole in the UK. Thank you very much.
Thank you very much, Steve. We do actually have time for one or two questions, if anyone does have one. Yep.
How can the graduates and the young professionals of today set themselves up for a career in oil and gas? The landscape is very different today than it was.
So that's a great question. How do we set ourselves up for success? I think certainly some of our geophysicists are very numerate, and some of our geologists who are used to reservoir modelling and statistics are very numerate. I would encourage all of us, either when we're in training, undergraduate masters, or even when we're in employment, to seek out some training on data science, just so we at least get a basic understanding of it. I would stress though that the role of the domain expert is still really key, right? So it's not just that we have to be able to do all this ourselves. I think the minimum is we need to know enough to have the conversation and frame the projects up right with the data science, with the statistical folks and with the computer scientists. So our role should still be, in my view, primarily as domain expert, but we need to know a bit more about this. We need to go and find out and learn a bit more about computing technology, a bit more about data, about statistical methods, so we can then have the conversation. Now, for the more numerate among us, and some geophysicists may choose this path, for example, we can go and retrain ourselves as data scientists. That is another option that some people will choose to take. But I think the role of geologist is still, and a scientist is really critical, because we're still the domain expert. Because again, the subsurface is undersampled, and you've got to know what rocks look like to make sense of what we're doing underground. Good question.